Well, happy Tuesday. Hope you're enjoying the nice weather. It was really pretty yesterday. Today's supposed to be pretty good, right? All right, so we're going to get into streams, and then we'll probably do ethics on Thursday. I think so. We'll go about as far as we can go. Ethics shouldn't take the entire time, so hopefully we'll have a little time at the end to work on the project as well. And then next week, I'll be here just to answer questions, hang out, work on the project. Got nothing new planned to talk about, so it should be fun as we try and wrap that up. All right, so I think we've done some work with files. Does that ring any bells, doing streams, input streams and output streams from 150? Okay, cool. So we don't need to get super crazy with these, which is great. Let me fire up Visual Studio here. And this is week 14. Wow, I'm cruising. 14 streams. Really got to change that template. All right, so when we look at our streams, right, input and output to get things in and get things out is pretty straightforward with these ones here. We've done all sorts of working with stuff on the keyboard input when we grab data. Right? It works very similarly when we're going to grab data out of a file. No one's going to be typing it in for us. Right? And when we output things, instead of outputting to the console where people can see the text, we'll output it to a file. Right? So we're just changing this idea. Now, streams get super useful because we can actually keep data around when our program's not running. Right? Everything we've done so far has been the program runs and you have to give it something. Right? And when it's done, it doesn't go anywhere. That's it. It's all over. So it's not able to like really save any of that information anywhere as we go. So dealing with files and letting us store that information so we can use it later or update something and use it later is awesome. So we're going to go and grab some file input and file output. So if we want to do like store a gradebook, right? I can then have the list of, all right, here's now all the things I've already entered. So I don't have to enter all my assignments again. I don't have to enter all these scores again. I don't have to enter all the students again. It's not actually a very useful program. If I have to enter all your names every single time I want to start up a gradebook, right? No one's going to do that. Now, all of these files we're working with are just text-based files so far, which is nice because then we can just open it up and we can see all the contents. Makes life really easy for us. A lot of times when we're reading, though, we need to know what format it was written in for us to read it. Right? I need to know, okay, this line has this piece of information, this line has this piece of information, this line has this piece of information, and how many lines am I even expecting to read? If the only thing I do is just read all the data from the file and put it into a big vector, it's not as useful, right? So we need to kind of know what the format's going to be as we go. So a lot of times when we're dealing with input and output, you want to start with what the format you want it to be is, whether this is the format I want to read it in, or this is the format I want to write it in. Because they both need to be the same. So whichever you think is going to be easier for you to plan out, hey, this is the data I need to write, or this is the data I want to read, we can do it that way. So if we're going to make some sort of grade book, right, we did this, like I had a vector of something and made a bunch of students and things like that, we can have a little bit of fun with it. So let's add in, I'll add like a student class here. It'd be helpful if I could spell that right. Student. Oh, I did. Okay, I thought I typoed it. Class for student. And the student might have a string for name, might have a double for grade. I don't know. Include string. There we go. And use our namespace. Standard. Right. Nothing super interesting here for students. So name, grade. Maybe that's fine for them. Maybe we can have a list of assignments later, but this will get us started. So if I want to write a bunch of students, I wanted to have had a vector of type student here, right? Let me go include vector, and include student. We can make a vector of type student. Nope, there we go. Vector of type student. Here's my students. Now, if we want to ask for some input and then write it, right, we're going to think about what form we want to write this in. So I could put them, here's a name and here's a grade on one line and then another line, or I could do some sort of separator and I could split the characters out. Lots of different ways to go about it here. Doing separate lines is probably easy for now, but then I also need to know either how many students I'm going to have or what other sorts of information I'm going to have in this file as well, right? So if I'm going to make this sort of a grade book, maybe I might make should we do like a map? We could do a map where we have the name of the class. I don't know, that might be too fancy. So maybe we'll just name our file. So let me grab our streams here real quick. We're going to include iostream, fstream. Right, so if we want to write the file first, right, maybe we'll ask for some input here. So we can have a string for input, and while my input does not equal done. Do you think there's a student to be named done or something? I don't know, right? We can ask them. So we'll just see out, enter student name, name to add, and then enter a score, oops, semicolon there. And we can see into the input, and then we can see out enter a score, or the score for, even use their name. And then I might need to save this, right? If I'm going to overwrite input, I'm going to save it somewhere. Or maybe I can make the student then. Make a student. How about that? Make a student. And let's see. So if we're going to do this right, we should have our private section. We'll have our public section. So we can have a set name, given a string for name. This name is the name, and a set grade, double for grade. This grade is the grade, and we can have some get methods too. So set and string for get name, returns name, and a double for get grade. Oops, I got my caps lock there. Return grade. All right, so we can do sets and get. So we can make the student, and then we can set the name, set name to the input. Then we can have a double for grade. We can see into grade, and then we can set the grade to the grade. Very exciting stuff, right? Or done to be all done. And then I guess we do this if their name is not done. Ugh, that's annoying, but that's fine. If input does not equal, it's not done, we'll do all this stuff. If it is done, then we just skip, right? I guess we can move that one in here too. Right, and we just keep on looping. So eventually we'll have the student. When we're done with the student, then we want to add them to our vector. So we'll take our students, and we're going to push back the student. So I had a bunch of students. When all of that's done, then we want to write it to a file, right? So we can take for student in our students list. So we need to, when we're working with files, we do three things, right? You open the file, and you read or write it, and then you close the file, right? I want to make sure we close it when we're done. Now, if our program ends, it'll get closed for us, but it's better practice for us to make sure we explicitly close our files when we're done here. So this was the input stream. We want the output stream. Let me go find, where is our output stream? I just want to copy. It's reading. Goodness. I just want to write. I want to steal a writing file. File output, there we go. OF stream. All right. So before we go write everything, we'll make an output file stream. And if you have to have a comment that says it's an output file stream, why don't you just name it output file stream? Like, and some people love their comments, and it drives me crazy. They're not helpful. What do we want to call this name? Like, here's our gradebook. Now, remember, the .txt is really just for your operating system. C++ does not care. It doesn't need file extensions. They're just so your operating system knows what kind of file it is, and txt files are text files. So we know we can open them up as text files and view them without having to tell our operating system what it is. If it sees a text file, it knows it can open it as a text file. Just makes life easy. All right, and so that's our gradebook. So let's go and write it. So for every student, then we'll take our output file stream, and we want to, instead of cout, right, we just throw stuff into here. So we'll take our student.getName and an end line, and then our student.getGrade, getGrade, and an end line. So that should write the file for us of all of the students. Oh, I forgot to close it. My bad. It was just telling us we should close. Didn't finish copying. Write every student, output file stream, close. Try one more time. All right, let's add Eric. I've got 100%. I'll add Jeb. He's probably got 95. I'll add Vivi, 90, and done. And it's all done. Now, in the Solution Explorer, we didn't add any files here, right? But if we go and look at our file system, if I go open it up and just say Show in Explorer, now I have a gradebook txt file, right? It's not part of my solution, it's just in the same folder. So if I open up gradebook, I should have Eric 100, Jeb 95, Vivi 90. Awesome. And then that last end line, sure. All right, so we've got that one. So now if I want to start my program by reading from that file, we can do that too. That way I can go and load all the data. So I know the format it's going to be in, so I can add a bunch of students to the vector, right? Go repopulate it here. So we have our vector of students. And let's go see if we can open the file. Let's go back to here and see if they're open. Now, we want to make sure when you go and open a file, check to see if it actually did open or not. Because we might have typoed something or whatever it happened to be here. Or maybe we even ask the user, hey, what file do you want to open? And then they typo it wrong because we don't have graphical user interfaces where they can click a file. Why would you type a file name? It's a terrible interface, but sure, we could do that. So we'll make our input file stream. Again, input file stream. Don't leave a comment. It's so dumb. So should we ask them? We can have a string for file name. And we can ask them for the name of your gradebook to load. And we can see in the file name, and we'll try and open it. So we'll take our input file stream, open the file name. Now, they might have given us a txt, they might not have. Not really sure. We could try and look for a txt, and if we want to get fancy, we could just hope they told us a txt file. I'm not super concerned one way or the other here, whichever way you did it, but that's okay. And then if it's not is open, you couldn't open it. Could not open file named and add the file name. Now I'm not going to bail here because that's okay. We're just telling them we couldn't open it and we'll just continue on with the program here, right? No worries. If you wanted to bail, you could, right? And again, this returning like a non-zero number means something bad happened in main. That's the int main, right? When you return 0, it's supposed to be fine, life is good. Okay, so anything non-zero usually is bad. 1 indicates an error, you know, or a helpful comment here. If we did open it though, right, our else case then, now I can go through and read it. Now, if I'm just gonna loop until I'm done, right, I'm gonna keep going until I find the end of the file, really, or until it starts failing. You got these couple options as we're reading files. You can look for the status here. It stopped reading here, or until you found the end of the file on our extraction. Right, I kind of like the EOF usually. I don't know why they keep using, yeah, if we're not at the end of the file, let's keep going. We can do something like that, right? While we're not at the end of the file, excuse me, and we read successfully, right? This good bit, we're reading things successfully from the stream. If you try and read from the stream and it fails, there's still something there, just didn't read like you expect. So this is probably a better loop for us here. So we'll say, okay, well, we're not at the end of the file, and it's a good bit here. I want to load So I'm going to have a string for name. We'll take our name, and we're going to, instead of taking from cin, right, we're just going to take from the file. Right, here's our stream, not a console stream, this is from the file here. So we put file stream, and we'll have a double for grade. We'll grab the grade. And then if it didn't fail on us, then I can go and add the student. So we'll take our students vector, we'll make a student, sorry, so student.setName to the name, student.set. That's annoying to have to do it in 2 lines, isn't it? And if we have the code here, we can go fix that. So we can make our own function here. So we can have a student constructor, takes a string for name and a double for grade. We can call set name, given the name, and set grade, given the grade. Right? That way I can just make students here. That'll make life easier for me. Oh, I should have the no argument constructor, sorry. Student. We'll set name to just like empty and set grade. How about to 0? Have both constructors. All right, then we can make a student given name and grade, and take our students and push back the student. Right? And we just keep on reading the file. So then we should have a list of students when we're done here. Now, if we want, we could add in some sort of menu that could print out the student list, or we could add them who else they want to add. We got lots of choices here. So maybe we just print it out, right? Or we could ask them here. So our input here, well, it's not done. How about enter 1 to list students, 2 to add a student. Or done. To be all done. And then if our input's not done, then we can check, hey, if our input is equal to 1, we want to list our students. So do a quick little loop through our students. So this can just be cout now, right? We don't need to write it to the file. We're just going to go here, if that was it, right? And then else if my input was 2, right? Just write a little menu. Little tree here. Right, we'll keep asking for more input here. Oh, I guess we got to get their name too, don't we? Shoot. So instead of their cout, turn the student name. And we can cin for the input here. Awesome. I guess, yeah, that we don't even need if the input's not done. That's nice, because we can just say if it's 1 or a 2. Even better, saves us a little typing. All right, and then when we're done, we should then be able to rewrite the file at the end here, and it should overwrite. Remember, when you open the file, it's going to blow away what was there before. So here's our gradebook.txt. All right, so if we list our students, we see them all here. If I want to add a student, let's add, we'll add Journey. She's probably got a 95, and if I list them all out, I see her there. We can say I'm all done. And then my file, again, we'll go take a look at that. Show in Explorer. Here's my gradebook. Journey's at the end. So when I reload it, then if I run it again, it's all ready to go. So gradebook, txt, list all my students. They're all here. Life is pretty good. I can say done. I guess that should have been like a 3 or something. That'd be easier than a done, but that's fine. Now this was fine because this was the only piece of information here, right? Not super tricky because that's the only thing we were tracking. If we had anything more complex that we didn't necessarily know how many of something we're going to have, right? I think we've done before where students had assignments, right? And assignments had scores, right? So if we wanted to go add a class for assignment, let's add a new assignment file. So a class for assignment. Oh goodness, there we go. And then it has our private section and our public section. Public. So if we have a string for name, a double for points possible, and a double for points earned, right? Because that way we can figure out our score here. using namespace standard and include string. There we go. Right. All right, I'm feeling really lazy here. Let's go to our GPT tool. I don't want to type all the sets and gets. Right. C++ code for set and get methods, and default and parameterized constructor class with attributes. See if that works. Right. I don't have to write any of this. GPT. All right. I guess this is still better than typing all of it, though. We can wait a little bit, right? Here's what I asked for. Sure. Why not? Assignment. Look at that. It even came with comments. Look how pretty. Did you know that these were set methods? Did you know these were get methods? You guys are amazed, right? Like, why did they give us such garbage comments? It's terrible. This is a parameterized constructor. This one's the default constructor. It's very exciting. Sorry, maybe I shouldn't make fun of it so much. Apologies. All right. Ooh, it's using that fun syntax. Have you seen this before, where you set the values with the colon syntax here? So instead of it being explaining this equals this, this equals this, this equals this, some of you have seen it before. Just another little shortcut here. Init name, init points possible, init points earned. Why init? Sure, I mean, whatever. Given a name, given points possible. Well, this one wants a reference to the string. Doesn't want a copy? Interesting. Okay, sure. All right, but now we have an assignment, right? So then student then can have a list of assignments rather than just a grade here. We can change this to make it a list of assignments. So maybe we have then a vector, and then we have a vector of type assignment. Oh, we got to include assignment. Vector of assignment, assignments. So now I don't need name and grade, right? I just need, here's name, set name, get name. We don't have grades anymore. Now we could do set and get for assignment here. That's one's a little bit tricky to pass it all in. We could, I guess. So a vector of type assignment, get assignments, return assignments, and avoid set assignments, given a vector of type assignments, oops, that's singular here, that one's plural. This assignments. And we can do that. So I can have a list of assignments. Then if I wanted to, I could have the get grade. So double for get grade. Right? I would compute this then, right? And figure out for all the assignments. So I'd have a double for total points possible. I don't know, starts off at 0, and then a double for total points earned. Starts off at 0, and then for assignment in assignments. Total points possible. Oops, come on, where'd it go? Total points possible. Assignment.get total points. Assignment. That's 3 S's. Goodness, I can't type. Get points possible. And total points earned. Assignment.get points earned. And when we're done, we can return total points earned divided by total points possible. I think that arithmetic checks out, right? Now the problem is if we have no assignments, we're going to return 0 divided by 0. It's probably not good, right? Maybe it's okay, but you know, we'll figure it out. All right, so you should be able to get grades out, get assignments. Now, when we go to write this to a file, though, I need to know how many assignments there are for reading it. I don't really need to care how many assignments there are for writing it. I can just write them all, but I need to know how many there are that I'm expecting to read, because I can't just say, hey, grab this and grab this until I'm done. There's not going to be pairs here. So this needs to be a little trickier now as we're going with this. Right, so we've got the student name. We'll come back to the assignments later as we go. We'll come back to score. So we got the name. Now we need to figure out what's happening with all these assignments, right? So we're not going to output their grade necessarily here. What we want to do is see how many assignments do they have, and then we can write that. So I can take my output file stream, and I can take students.getassignments.size. I can write that. So if I'm writing how many assignments they're going to be, when I go and read this data, I can say, okay, read the name. The next thing will be how many assignments I'm expecting to read. Okay, so I'll get the name, and then I don't have a grade here. I'll have an int for number of assignments. I can see in the number of assignments, I can make a student, and then for int, I don't know, assignment 0, assignment is less than number of assignments, assignment plus plus. Now I can go read more information, right? For every assignment, I'm probably going to write all that information, right? So I wrote that, right? And I got to do another loop then, and then for assignment in my student get assignments. This seems a little silly here, so we can say, hey, auto assignments equals student get assignments. This is why auto is really nice, right? If you don't have to type all that, like the vector of type assignment, you can just say it's an auto, but we know it's this type because that's what the get method returns. I haven't used autos a whole lot before, but they're super handy as these things get long here. Okay, and then for assignment and assignments here, now I'll take my output file stream, and we're going to write assignment.getName and an end line, and then you want to do, this will be get points possible and get points earned, right? So if we write them in this format, so here's the name, here's the number of assignments, here's all the assignments. When I go and read it then, I'll know, okay, let's go for this number of assignments, let's go read the assignment. So I'll have a string for name, a double for points possible, and a double for points earned. And then I can take my input file stream and grab all those things, right? Grab the assignment name. I already got a string for name, didn't I? We'll call this assignment name. Just in case, let's do assignment name. And then points possible, input file stream, points earned, right? And then I can make that assignment, right? So then we'll take a vector of assignments. So we'll make a vector of type assignments, and we'll take this vector and we can push back a new assignment given the name, the points possible, and the points earned. Right. You can do it all in one line if you don't want to have two lines, right? I'm just saving a little bit of typing here. Usually we do it on two lines, but we can just create this inside of the pushback here, right? So this will read that many assignments then, right? So right now it's not actually going to work because the file's not in that format, right? So here's the student name. Now, managing assignment lists is going to be a little bit awkward here, but that's fine. We can go get the list here as we go. So enter the student name, we'll set the name, and then we could ask them for assignments. How about a string for assignment name, and while my assignment name does not equal done, enter an assignment name or done, and then my assignment, we can see in assignment name, and if my assignment name does not equal done, I hate doing this twice here, but that's okay. And we can have a double for points possible, and a double for points earned. See out to the points possible. This is the boring part, sorry. And then we can see in points possible. And points earned. We'll just copy paste. Points earned. Points earned. Then we can make the assignment, and we can add that to the assignment vector, right? So we need a vector of type assignment. Type assignment. Assignments. And we do the same thing, push back an assignment, given the assignment name, given the points possible, and given the points earned. Very exciting, right? And it'll just keep on going until we say we're done. So this should now let me do that for all the students added as gradebook. So I'm going to start and not load gradebook because it'll crash on me here. So if I just say test, couldn't open the file name test, that's fine. So we want to list the students. There's no students to list. We got to change our list here too, don't we? I guess we can leave it as is with their get grade, but maybe then for assignment in get assignments, see out assignment.get name. Now, probably we should give them some more information here. This is a little weird that it's just numbers here. I don't know, like, should we say points possible? And then the assignment points possible. Get points possible. And then points earned. Points earned. Get points earned. All right. So now my list, I should get something a little bit nicer here. So again, let's load like a test here. One, there's nothing to list, so let's add a student. Let's add Eric, add an assignment name. How about project 1? That was 10 points, I earned 10 points, and we'll say done. So on my list, I get Eric, not a number. Didn't I add an assignment? I should have had 10 out of 10. Negative, not a number. Uh-oh. All right, so something was wrong with my get grade. Oh, I never added the assignment, sorry. That's why. So we have the assignment vector, but we never added it now, right? So then when we're entering all those assignments, we pushed it back. When we're done with all of that, take our student set assignments, there we go, given the assignments. Make sure we set it. Test didn't load, let's add a student, we'll add Eric. Project 1, 10 out of 10, done. So we list, here's Eric, scores 1. Oh, I guess is there really a percentage? Oops, right, because I have 10 out of 10. Grade's a little funny, but that's okay. And then done, and we should have a file. Right, so now the gradebook file should have Eric, there's one assignment to read. Here's the assignment, here's all the points. So it should go and load for us when we run. So gradebook.txt. We list, oh, it didn't load it. Okay, so when we loaded, maybe I forgot to add that too. Let's see. Yep, we did the same thing. I pushed back to the assignments when I never set the assignment. So here's the student name, here's all the assignments, pushed back. The student, we got a set, so student dot set assignments, given assignments. Give them the list of assignments. Then we can go and add the student to the vector. All right, let's try that. So this one's good to try it, right? Gradebook.txt, list. All right, there's Eric, here's points. Everything looks good so far. Excuse me. Again, we should change up the menu, let me add assignments to existing students and do all sorts of other fun things here. But does that part make sense where when we don't necessarily know how many pieces of information we're going to have, we need to tell it, and now we know how many we expect to read. Right? Knowing the format of the file ahead of time lets me read it and write it in a way that I can read it and write it. Right? If all I were to do is dump out a bunch of assignment names, I wouldn't know when the next student starts. Right? How would I differentiate between assignment? If you wanted to, I could like prepend, here's the prepend, assignment, colon, and I could look for the text of assignment, colon, and I could look for the text of student name. You could do other options too. But I like this sort of option. Makes life a little easier, and I don't have to do as much string searching to say, okay, is this a new student that I'm entering, or is it a new assignment here? So there's tons of different ways you can do files when we're storing data here. As long as you know what the format is, go for it. It'll work for you, right? That sort of thing. If you don't like them being all on one line, or if you don't like them being all individual lines here, you can make student fit on one line. That's one option, right? You could say, hey, let's take one line here, and I can read one line at a time, and then from that line, I can go and parse it as well. So I could say, all right, here's the student name, and then maybe I'll put a character, and then I'll just start listing out assignments. So from that individual string, we could go and grab all these things here. So when we're dealing with our input streams, input string streams, we could load one string at a time, like, hey, here's the line Amy Smith 19, right? We could go and parse that individually, just like you can take out of a file, you can take out of CN, you can grab individual pieces of a large string. So that's another option here too. We could write it all to one line. I could read one line as one student, here's the name, and then here's all the assignment pieces. I could just loop through from there. So lots of different ways we could go about doing things with our students here. Like they gave you that, I think the phone numbers was silly, but that's fine. Some fun examples there. Does that part make sense for strings? Lots of fun stuff with strings. I don't think that ended up being, yeah, that wasn't one of the outcomes, interestingly, right? Efficiency of algorithms, test cases, stub procedures, trade-offs, easily modifiable, linked list stacks and queues, various sorting algorithms into program design. You use the fast one. I don't know why there's various ones. You use the fast one, right? That seems a little silly. Existing class libraries, all the stuff that's in the standard template library. We create our own classes to solve problems here. We use data abstraction, data hiding, functions, inheritance, and pointers, and then work with Unix file system and Unix shell commands. I think we've hit everything on the list here. It's not been too bad. So we have ethics on Thursday, and then next week, group project work time, final project work time. If you're not in the group, that's okay. A couple of people have emailed me. I've set up shared repositories. That's a nice way to do it. You can also email the files back and forth, and I'll cry about it, but that's okay. You don't have to worry about me. And hopefully we get it done by the 18th, and then the week after, all we have to do is show up at 8 in the morning, oh goodness, and present. Okay, yeah. I will bring coffee. I will have my thermos of coffee for anyone who wants it here. That sound like a plan? So we're about at the end. It's been a lot of fun. I have to go through and add all these scores. I apologize. I thought I did it. I think I'm getting my classes mixed up here to add all the scores in. So hopefully you did your self-assessments for these. I'm going to look at your code and then look at your self-assessment. If they look like they match, you get your score. If you told me you did 100% on everything and you don't have all the code there, you're not going to get the points you gave yourself, right? You just can't lie about it. But if you gave yourself an honest assessment, great. It'll go through. So I can get that added in here. I got about half the midterms done. I got to come back. I thought I finished. I'm getting all confused myself here. If you're missing labs, I'll still take them, right? If you'd like to get the work done, please get it done, right? I know they're late. I don't usually take things late. That's more like the projects I've gone over solutions. The one lab I did go over the solution with linked lists. There was not a whole lot to do here with that one because we kind of went over it the next day or the next Thursday. Other than that, I'll get those in for you. And then Canvas, I'm sure, is telling you about the course evaluations every time you log in. So these are part of the review process. Every year I turn in an annual review to my department chair. The poor guy, he probably reads them all. I can't guarantee that he does, but all of the reviews are part of my review process that I turn into him. He probably reads them. I read them all. I appreciate the anonymous feedback here. I've changed how I do the course over the years based on some of the feedback here, try and tweak things, make things work well for students. So would appreciate if you take a few minutes to fill it out. The good, the bad, and the ugly, all perfectly fine. We do like your input here, and it probably gets looked at by the department chair. I feel bad. I can't promise that he does look at it, but we've talked about reviews before, so I know he has at one point looked at them because they came up in a conversation. So looking forward to that. So lab today we'll do on files and streams. Next week we will have a short lab on ethics as well. We'll have a little bit of time the following two. So a week from today we'll talk about ethics. On Thursday, and we can do a quick little ethics lab, because that was one of the things we need to assess as well. So that one's pretty quick. It's a lot of fun, and that one's actually a little bit of writing. Interesting. I mean, there's not really code we're going to do for ethics. Hopefully that didn't surprise you, but just a little bit of writing for that one. Goes pretty quick. All right. It's been a lot of fun. Look forward to seeing you folks around. Hopefully you've had a chance to look for classes. I don't know if you're taking any summer classes. I think the schedule's up. I don't think registration's on quite yet though, right? They posted the fall schedule, right? I think they did. Didn't they? Class schedule. I thought they did fall. Yeah, we got fall out there. So if you haven't looked yet, go look for fall, right? Talk to your advisor, make sure you're taking the right classes that you need, and we'll go from there. All right, that's all I got today. Thanks so much. I'll see you for lab.